Montessori. We're just warming up for Math with Mrs. Lehman. This is Mrs. Lehman with my third period class. Say hello, please, everyone. Hello. They're all revved up, ready to go here. So, today we are taking a new adventure. It's very exciting. You have a shiny, new, pink it's not shiny, actually. A pink module book for Module 5. It's very exciting. This module is all about geometry stuff. All right, that's the technical term, geometry stuff. It's about area, surface area, and volume, and we are going to do lesson 1 today. Right, so I would like you to all get into my time machine and travel back to kindergarten for the next minute or so. All right, lesson 1, opening exercise, says that we need to name each shape. So, boys and girls, what is the first shape here? Everybody. Oh, that was weak, kids. I know it's kindergarten and you haven't learned this a long time, but let's try that again. Yay! Now, who can tell me what told you this is indeed a triangle? Willow.
There's 3 sides.
Very good. 3 sides equals a triangle. Now, another question for you. Now let's transport to maybe 4th or 5th grade. What does this little box mean? William.
That's a right triangle.
Very good. You are correct. That is a right triangle, meaning it is formed with, obviously 3 lines, but 2 of those lines are perpendicular, meaning they form a 90-degree angle. Whenever you see like the corner of your papers, for example, those are all 90-degree angles. They are right angles. All right, can anyone tell me what this is right here? Liz. Nope, it's close, but a rhombus is like a square that looks like it got sat on. This is more like a rectangle that looks like it got sat on. Jaden?
That is a parallelogram.
Very good. That is a parallelogram. Now, what makes a parallelogram a parallelogram? Well, it has 2 sets of parallel sides. But there is a tragic story about parallelograms, kids. You know, they have these sides, you know, that if they went on forever, they have a lot in common, but they'd never meet. That's sad. Parallel lines never meet, get it? They go on and on. They run parallel, they never intersect. But anyway, so these are parallel lines. This is a parallelogram. Did I spell that right? I struggle sometimes.
Yeah.
That's right? You think? Oh, it's right up top. Geez Louise, use your resources, Mrs. Lehman. You tell the kids that. What are you doing? Pull it together. All right, now, what do we call this shape, boys and girls? Maya, nice and loud.
A triangle.
Very good. That is also a triangle. Now, if we want to be real nerds here, we can describe this triangle even more. Liz, what are you going to say?
It's cute.
Stop calling shapes cute. It's just weird. It's just weird. She said it was a cute triangle. She's right, though. It is an acute triangle because all of these angles are less than 90 degrees. This video is so full of bad jokes already, and we're only a few minutes in. All right, now, it's only downhill from here, everybody. I'm sorry. And then I'm going to make an assumption, which you can't really make in math unless you have some proof, but I'm going to pretend the proof is there. If all 3 sides are equal, we would call that an equilateral. I'm struggling, guys. The spelling. That does not look right to me. Equilateral? Good gosh, I don't think that's right. I think this is right. Sound it out. Equal. I don't know. Who cares? All right, so equilateral. Listen. You can survive without knowing how to spell that correctly right now. We'll look it up later. I just don't have time right now. Told you it was all downhill from here. What is this triangle? I'm going home. It's official. All right, Deja, what is that?
A rectangle.
Very good. Thank you for saving me, pulling me out of this terrible deep dark hole I've dug for myself. All right, that's a rectangle, and this one is something very unique. It has one set of parallel lines. The other two are not parallel. What do we call that, Jaden?
A trapezoid.
A trapezoid. I mean, it kind of looks like a spaceship, doesn't it? Let's get back in the trapezoid. Gonna go to the planet. No? That's just me, huh? Okay, so trapezoid. My trapezoid's almost here. I'm gonna travel back, alright? Alright, I'll calm this down. It's getting a little out of hand. Now, before we do these exercises, we are going to run through some different things. So actually, we're going to go back to that other page. Now, you guys already know the area formula for some things. The formula is just, an equation that you can plug into to solve for, specific things. Like, we have already found the area formula for rectangles to be length times width, right? With a parallelogram, we're not going to do length times width. The area formula, spoiler alert, is base times height. All right, base times height. So, the big thing is we have to be able to identify what is the base, what is the height, even when the math wizards try to trick you and give you lots of things that are not important for each problem. So, before we do that, I would like to share an example with you. I'm going to be on the next page here for a little bit, on page 2. So when you go to the doctor's office and they take your height, they make sure that your heels are right up against the wall and you're standing straight. You're standing very perpendicular to the base, which is the floor, correct? All right. I know you cannot see me doing this, but this is what a lot of kids seem to think. They think when you're finding the height of a parallelogram, because the lines are slanted, they just use the side length. That would be like going to the doctor and saying, all right, take my height. They would look at you like you were insane and tell you to stand up straight. Now, I was giving this example a few years ago to some kids, and I said, you don't want to do that. You don't want to go to the doctor and stand, all crooked when they go to measure your height, because you're going to get in trouble. If you don't believe me, try it. Of course, I was kidding. And sure enough, there was a kid who had a doctor's appointment that next day and came in and said, Mrs. Lehman, I went to the doctor's and I tried what you said and I didn't stand up straight when they went to take my height. And I'm like, oh my goodness, what happened? Why did you do that? I was just kidding. And he said, well, I got in big trouble with my dad. I got grounded. And the nurse acted really mad at me. So they told me to stand up straight. So remember that example when you're trying to find the height of parallelograms, okay? You're looking for a perpendicular line, all right? You're looking for the base and the height to be perpendicular to one another, unlike this kid who got grounded by his very strict father, all right? So there are different places where you can draw the height, all right? In this example, you could go straight down from the corner and form a right angle that way. Notice it's a dotted line. You're going to draw that on your notebook right now on page 2A, all right? Because that is not actually part of the shape, it's just indicating the distance from the bottom and the top, okay? So right here would be another place you could see the height. Now, sometimes the height is not indicated on the inside of a shape. Sometimes it's coming down from the outside corner, right? Which also shows the height. So any of these could also be used as the height. Now with a rectangle, because it's a perpendicular line with the base anyway, the side is, that's why it's just length times width. With a parallelogram, we have to figure out what the height is, because we need that that perpendicular line. So, there you go on that one. Let's go ahead and try B. All right, again, start at a corner and go all the way up or down. Do your best. I mean, There's only so much we can do here. Now, we can do it on the outside as well. So, I had a kid earlier today. Do not do what I'm about to do in red, everybody. They went like this, and they came way out here. Like, that's a little unnecessary, children. All right? So, we are just going to keep it as close to that shape as possible. So, right, I'm going to do it in blue again. And you're looking for, hopefully, that perpendicular line indicator, the right angle box that you'll see in corners that are right angles. Right? If you see that, then you know you're golden. All right, example C is a little bit different because that would be, if you, all right, don't write this down, children. Does that indicate the base? Or the base, wow, I am going home. Does that indicate the height? No, it doesn't go all the way from the bottom to the top of the shape. So we have to, in this case, go outside the parallelogram and do something like that. This would be the height. So the key to finding the height is looking for a perpendicular line formed with the base. Okay? So a right angle, whether it's inside or outside of that shape. So they could tell you that this is a distance of 10 and this is a distance of 5, maybe, I don't know. The one you care about, if you're finding the area, is the 5. You would care about the 10 if you're asked to find the perimeter of the shape. But when you're doing the area formula, it clearly calls for the height. All right, so let's go back a page and practice some examples now that we know the difference between the height and the base. Now, unfortunately, in the module books that got copied, the little dotted lines are not in there. So you guys here in class, and if you're at home with these particular module books, you might want to draw those little dotted lines in to represent the height right now. All right, so Module 5, while you're doing that, I'll talk about this a little bit. Module 5 really set you up for success. Module 4 set you up for success in Module 5 because you learned about equations. You learned about substituting for a variable. You learned how to evaluate using any order of operations questions. And then you obviously know how to isolate the variable or solve an equation, okay? So that's all this module is, okay? Is we're plugging in pretty much. There's some other stuff toward the end. But for a while, we're just plugging into formulas. So when you're doing that, you always write the formula. Area equals base times height, all right, in this case. So step 1, identify the shape that you're looking at. All right, if you're asked to find the area, which we were here, it says find the area, you would write the formula. So fill in what you know. Do we know the area yet? Obviously not. Do we know the base? Yes, we do. That is 6. What is the height in this example? 4. So what is 6 times 4? 24. Yep, so 24. Now the unit for area is always going to be units squared. Right? So in this case our unit is centimeters. So we're going to say centimeters squared. Now it's not 24 squared, it's just the unit squared because we're talking about what surface that covers. Okay? And that means we would need 24 1 centimeter by 1 centimeter squares to cover all of that section. Does that make sense to everyone? Right, so if you look at the floor right now, we have some tiles, and they're about a square foot each, right? Because they're about a foot wide and a foot long. So you may see it like this, so I'd like you to write this down because I don't want this to confuse you later. So you may see 24 centimeters squared with the abbreviation, or you may see it like this, squared centimeters without the exponent of 2, and they just write squared units or squared centimeters, squared feet, whatever it may be. So either way. All right, this next one, let's go ahead and do that. Area equals base times height. All right, we don't know the area. We're looking for the base. What would the base be here? Somebody said over here, nice and loud. Jasmine does not have it in her ability set to be loud, at least in class. I'm sure at home some parents may argue, but here you go, Jasmine.
25.
Very good, thank you. 25. All right, you know this is a sweet group of kids when you tell them to yell at you and they don't. All right, 25, and the height is, everybody, 8. It is not 10, because 10 is you go into the doctor's office, slanted like this. I'll draw a little stick figure to show our viewers what I'm talking about. So 25 times 8 is what? William? 200, very good. So what unit would I use here? William, again, nice and loud. Meters squared, very good, because we're multiplying meters times meters, so that's going to give us a square unit. All right, meters squared, or squared meters. Okay, any questions so far? All right, here's my little drawing for the viewers at home. Say, here's the floor, and here's the little height thing right here, and the person getting their height measured is like leaning over like this. Hey, you know, that would not work. They want you to be standing perpendicular to the floor, right? This is yes. This is no. Okay. All right. Anyway, moving on. You should see Mr. Fermata we got here. I learned a music term the other day. I kind of feel like drawing it, but we don't have time. All right, so should I draw it real quick?
Yeah.
I don't know anything about this stuff, but they tell me that this means fermata, and somebody said, yeah, our orchestra teacher told us that about something that looks like a belly and a belly button. I'm like, what? And so then I was like, oh, well, let's draw it then. Oops. Got his little legs coming out. Oh, what happened there? What happened there? Okay. All right. Now, of course, he has to have a crop top. And I gave him some cool hair. Yeah. And he's got arms. Now, I drew him with 4 fingers in the other classes, and I got picked on for that. 1, 2, 3, 4. He needs one more. All right. 1, 2, 3, 4, 5. Yeah. There's Mr. Fermata. Yeah, thank you guys. And it all started from this right there. That little belly hanging out. Anyway. A crop top trend that can't die quick enough. Okay, let's get out of this. All right, that was a little fun break. Now we're going to go back to math. Area equals base times height. So, the quote-unquote math wizard tricks that they're throwing at you here, pretty much, they're giving you more info than you need to just find the area, right? You might need this side 11.5 if you were asked to find the perimeter, but you're not. You're asked to find the area. So the base is what here? Well, not everyone I want to know. All right, and then the height is
7.
Yep, and 12 times 7, last time I checked, was
84.
84. What unit, everybody?
Feet
Squared. Very good. 84 feet squared. Now, we're going to do an example where they give us the area. So, for example, let's say they give us the area is 84 feet squared, but they don't tell us the base, right? So we're gonna have to use our equation solving skills. So that's what we're going to do now, down here on question 3 on page 2. All right, so some of these problems really intimidate children. You really have to read each problem twice, and I'm not just saying that to waste your time, like I have a lot in this video. I am saying it because it is beneficial if you really read it over, underline the key parts, figure out what have I been given, what do I know. You can typically overcome that mental block of thinking that this is difficult, and you psych yourselves out, and you shouldn't be doing that. All right, so it says if the area of a parallelogram is 35/42 centimeters squared and the height is 1/7 centimeters, write an equation that relates the height, base, and area of the parallelogram. Solve the equation. Let's read that again. if the area of a parallelogram is 35 over 42 centimeters squared, so they're giving us the area, okay, of something, this parallelogram. We know the area. The height is 17 centimeters. That's important to know. We have to write an equation. So we know an equation has a what in it? Equal sign. Thank you, Tim. It's an equal sign, right? That relates the base, the height, the base, and the area. So do we know an equation that would have area, base, and height all in it? We just practiced it 3 times.
A equals base times height.
Beautiful, Willow. So we're going to write what we know. We know area equals base times height. Now, they have given us some values that we can plug in here. So let's look. It says the area of a parallelogram is 35 over 42 centimeters squared. So where would I plug that in? William.
Under the A.
Very good. So we have been given the area 35 over 42. Have we been given the base? No. So we keep that an unknown value, B. We're going to try to solve for B. Now, have we been given the height? Yeah. So what can we substitute in? Plug in for the height. Mackenzie.
17.
Very good. 17. So, some of the kids have struggled when it comes to solving equations with fractions. So, let's think about this. We have, 35 over 42 equals B times 1/7. So we have a multiplication equation here, right? So we want to get the variable by itself by doing what operation? What's the opposite of multiplication? Division, yes. So we're going to divide by what? By what? Anyone? Euler, yes?
7.
Well, we're going to multiply by 7 because we want to divide. We want to divide by this, 1/7 right here, okay? So with a fraction, when you divide, remember the copy dot flip, you multiply by the reciprocal. Very good, Tim. So we're going to multiply by the reciprocal. Now I'm going to show you why this works, right? So if we multiply this by the reciprocal, what's the reciprocal of 1/7? Jada, nice and loud. Yep, and so just 7 over 1. Multiply this by 7 over 1. Now the reason this will isolate that variable is when you look at this, 1 times 7 is 7, right? And that would be over 7, or you can just look at this and simplify before you multiply any of these things. Okay, so that's going to only leave B on the side. We've efficiently isolated the variable by multiplying by the reciprocal. Now if you look over here on the left-hand side of our equation, you're going to look for things that you can factor out, you can simplify out before we multiply. So who can tell me about 7 and 42? Do they have any factors in common? Yes, what's their common factor? You're taking it to the next step. Their common factor is not 6. Tim? 7. Very good. So 7 goes into 7 how many times? 1. 7 goes into 42 how many times? 6. That's where you were coming up with that 6, I think. All right, so 1 times 35 is what? 35. And 1 times 6 is 6. Very good. So this kind of problem requires you to have some good fraction skills, which seems to be an area of weakness. So if you ever have free time, practice your fractions, multiplying, adding, subtracting, dividing, all that good stuff. All right, so 35 over 6. We don't want to leave it like that. What do I need to do? Turn it back into a what? Yep, a whole number, a mixed number. All right, so we're going to take 35, divide it by 6. Remember, that bar means division, right? So if we take 35 divided by 6, you're going to say 6 goes into 35 5 times. That gives you 30. Subtract, you get 5. What do I do with the 5? I'm not going to do a remainder. I'm going to put it up and use it as my numerator and use that as my denominator. So you would say that the base equals 5 and 5, 6. Now we have to label that. Would that be centimeters or centimeters squared if we're dealing with just the base? Just centimeters, good. So centimeters. Now, if we wanted to check this, which for time's sake I don't think we're going to do right now, if you wanted to check this, what could you do to figure out if you were right? It's hard to pick when everyone has their hand up. I guess I'll call on you, Willow.
5 and 5, 6 times 6 equals 30. And see if times 6 to see if you get 35.
Oh, okay, well, what if we plugged it in here, though? If we plugged in 5 and 5, 6 as our base, multiplied it by 1/7, what should we get as an answer?
42.
35 over 42. All right? I'm pretty sure you would not struggle with this problem if I were, I'm going to change it for a second. All right? If we were to change this, let's do, let's just say this were, oh, what am I writing? Let's just say this were 42 and 7. All right? So if we said the area is 42, the base, we don't know, the height is 7. If you wanted to solve it now, you would have no problem. You guys just did very well on this part of your test. You would divide each side by 7, right? And you would get the base equaling 6, right? You guys would solve that in about 3 seconds and be really good with it. It's because of the fractions where you guys are getting really lost with this. It's because you're rusty with the fractions, okay? We got to try to dust that rust off. I don't know if you can dust rust off, but anyway. You might just end up with a big hole. Okay, so anyway, anyway, draw and label the height of each parallelogram. Pardon me. All right, so I'm gonna let you guys do that on your own. Let's look at these examples. Oh, those are easy. Let's go to the next page so I can help you with some of these fraction business before we go. We've got a few minutes before the end of class. Your homework's going to be to finish anything in this problem set, which is a total of 9 problems, but they're really not terribly difficult. So, let's look at number 5. Notice all the different gobbledygook they've got going on there, right? It's just to trick some kid that wasn't paying attention in class, right? We know the area formula for a triangle. Goodness gracious. For a parallelogram is what? Base times height. So everybody should write that down right now. Write it down over here too, because that's what we're going to use. Area equals base times height. Okay, now we have to figure out which of these numbers we need. So for example 5, what do we want to use as our base? Raise your hand if you know. Liz, yell it at me. Very good. Very confident there, Liz. You're correct. 2.5. Alright, this is not part of the shape over here. We don't need that info. Alright, what do we need for our height? 7 2/3 or 5 1/4? Mackenzie, yell it at me.
5 1/4.
Very good. We want the height. Notice, you're looking for that perpendicular line. Okay, so we're going to be using 2.5 and 5 1/4. I'm going to let you guys do that math. Let's plug in though. The base we said is 2.5. The height is 5 1/4. I'm feeling nice today. I guess we'll do this one together. Alright, so what do I need to do with these before I multiply them? Gotta get them in the format, right? What do I need to do with 2.5? Somebody yell it to me. Mackenzie. Well, an improper fraction. So 2 times 2 is 4 plus 1 is 5. So that's going to be 5 halves times 5 1/4. 5 times 4 is, plus 1 is
21.
Yep, 21 over 4. All right, so to multiply fractions, you just multiply straight across. 5 times 21. You probably have to go to the side to do that. What are you going to get? 105, good Tim, divided by or over 8. So we don't want to leave it like this. That's kind of sloppy. So 105 divided by 8. 8 goes into 10 one time. That gives you 8. You subtract, you get 2. Bring down your 5. 8 goes into 25. 3 times, you're going to get 24 with a remainder of 1. We don't do remainders, we're going to put 1 over 8. So your answer is the area equals 13 1/8, and then the unit will be what? Inches squared. Very good. Okay, so I know we moved through that pretty quickly, but I want to give you an example. So there's a few questions where you have to do that, some with fractions, some without. And then this question 7, it says Brittany and Sid were both asked to draw the height of a parallelogram. Their answers are below. Are both Brittany and Sid correct? If not, who is correct? Explain yourself, right? Explain your answer. So you have to decide, are these both valid, or is only one right? If you're grading these papers, which would you say is right, or would you say they're both right? Okay? And then down here, do the rectangle and the parallelogram have the same area? So how do we find the area of a rectangle? Well, but when it's a rectangle, it's going to be length times width, right? Because our width is essentially our height. So in here, we're going to use base times height. All right, so that's your homework. Then you have one more on the next page. You're going to actually find those areas first. And it says, this one has decimals, all right? But you're doing the same thing that we did before, where they give you the area, they give you the base. You've got to find the height. So I'd like to thank everyone for staying with us through this video. Please don't forget to like and subscribe. I think we're up to 80. So thanks for watching. Have a great day.